right, so week 4. Let's go ahead and get this in. So question number 1 says vertices Q and T of triangle QTU are located on opposite sides of rectangle PRSU as shown in the diagram below. And then they ask you, what is the value of x? So we're looking for the value of x. Well, x is right here, so if I knew what x was, then I would know the answer to this question. How do I do this? This is one of those problems where once you know what you're doing, the process is pretty easy going forward. Well, one of the things that you need to learn about triangles is that this angle right here is called an exterior angle. It is supplementary to this angle right next to it. But what it also is it is congruent or equal to those two angles there. So the sum of those two equals the exterior angle. So in mathematical terms, x plus 2x equals 132. That's the problem that you have to solve. So if you have x, which we call it 1x, plus 2x, you get 3x, which equals 132. Divide both sides by 3 to solve for x, or isolate the variable. And you find that x is going to be 44. So x, this answer that we're looking for, is 44. As an extension, if they asked me for angle Q, which would have been 2x, then that means it would have been 2 times 44, which would have been 88. We also could have been asked in this problem for angle QTU, this angle here. Well, then that would have been 180 minus 32, which would have been, I'm sorry, not 32, but 132. So this angle here would have been 180 minus 132, which would have given you an answer with an 8, so that would have been 48. And the final thing that you need to know about this is that 48 plus 88 plus 44 all add up to be 180, because any three angles, all three angles in a triangle will always be 180. But let's get back to the problem. The problem asked you for x, and x is 44, so I bubble in 44. Number 2, a truss is a triangular structure that helps to support the roof of a building. The truss above has one side measuring 12 feet and another side measuring 16 feet. How long in feet is the third side of the truss from point A to B? So it said that the first side of the truss was 12 feet. So here's that side, 12 feet. The second truss was 16 feet. And so here's that side, 16 feet. They asked you for the length of AB, which would have then been the length of this side here. So that's what they're asking us for. And so they're asking us for AB. What you have to recognize is that what they're dealing with here is a right triangle. Anytime you see a box right there, you automatically know that your triangle is a right triangle. When they give you two sides of a triangle and it asks you for the third side, you can use a Pythagorean theorem. So that says a squared plus b squared equals c squared. The thing you must know when you're setting this up is that the side that is across from the right angle, which in this case is the side that he asks us for, must always be C. These two don't matter. This can be A or B and this can be A or B, but this side can only be C. It has no other alternative. So knowing that, if I assign 12 to be A and 16 to be B, I can just plug it in. So 12 squared plus 16 squared equals C squared. The next thing that is screaming at me to do is to evaluate and simplify this side. So 12 squared is 144, because it's 12 times 12, plus 16 times 16, which is 256, which equals C squared. The next thing it's telling me that I have to do is to add these together. So 144 plus 256 will be 400, which equals C squared. Take the square root of both sides to undo the squaring. If it was squared, you undo square by doing square root. So square root of 400 square root gives you 20. And that C squared, when you take the square root, will give you C. So I now know that the side that I was looking for, side C in my right triangle, was 20. So my answer is 20. Number 3 is a problem that we should be relatively familiar with, but Austin saved $450 from his pay and joined a golf club to improve his game. He paid a $100 membership fee and also pays $15 for each round of golf he plays. Austin used the following inequality to determine the number of rounds of golf he could play, where 100 plus 15R should be less than or equal to 455, because that makes sense. The membership fee being $100 plus $15 for every round should be less than or equal to $455, because that's all he has. What is the maximum number of rounds of golf Austin can play? Well, to do that, we just simply need to solve this inequality. So 100 plus 15R should be less than or equal to 455. To solve this, we're going to subtract 100 from both sides. These will cancel. And so we have 15R should be less than or equal to 455 minus 100, which would be 355. Divide both sides by 15. These will cancel. And so R will be less than or equal to 355 divided by 15. And 355 divided by 15 is 23.6 continuum. Now, most people will get tripped up right here. So 23.6 is what we got from our calculations. But the question asks, what is the maximum number of rounds? So if you were the owner of the golf course and someone came to you and only had enough money to pay for 23.6 rounds, you would not let them play the 24th round because they don't have enough money. So the maximum number of rounds that they can play is 23. The other reason that we know that the maximum number of rounds is 23 is because it asks for maximum, and this number, my answer choice, must be less than 23.6. And 24 is not less than 23.6. So the answer must be 23. Number 4 is one that is relatively simple once you know what you're doing, but it can throw you off if you're not paying very close attention. So it says that these two triangles are similar. Great. So triangle DEF, which is going to be the triangle out here, D to E to F, and triangle G to E, GEH, are similar. Good. That means that the corresponding sides, so the right side, and the base and the base, and the left side and the left side should all be related to each other. So if I was to set up a proportion to solve, so what is the length of HF? I'm looking for HF, and HF is from here to here. I don't know what that is, so I'm usually going to call that X. I'm looking for X, but if you notice, it is not the entire length of either of the sides. So that means it's going to be a little bit more work than we're expecting or than we're used to. How do we set this up? Well, what are all the things that we know? We know that EH and GH are from the same triangle, and we have the numbers. So EH over GH is a pair we should use. The other pair that we should use is the entire right side, because EH was the right side of the small triangle. So the right side of the large triangle was EF. And the base of the large triangle was DF. So again, if I was to think about this from beginning to end, it's a little messy. So if I say the small triangle over the large triangle, and then I say I have the right side here, here's the right side, and here's the base. These are two fractions that should be equal to each other. Well, the right side for the small triangle was EH. The right side for the large triangle was EF. Okay, I'm going to cut this portion out right here. Okay, here comes the beginning of the new portion. So we said that if we have the small triangle and the large triangle, we have the right side, which is over the base. These should be two fractions that are equal to each other. So the right side of the small triangle is EH. The small side, or the base of the small triangle, is GH. The right side of the large triangle is EF. And the base of the large triangle is DF. That's significant because I cannot find the length of HF until I know the length of EF, unless I set it up the way that I'm going to show you now. So EH was 4 over GH, which was 5. It's supposed to be equal to EF, but what is EF? EF does not give us its own numerical value. It tells us that from E to H was 4, and from H to F was X. So if these were numbers, if this was a 3, we would have said 4 plus 3 and would have known as 7. But they didn't give us a number. So all we can do is show that we tried to add 4 plus X, divided by DF, which they gave us was 15. So to solve from there, we will cross multiply. So 4 times 15. And here's why I've always said when you're setting up proportions, do not try to do all the math out in one step. So that should be 5, but since we're multiplying by this whole term, we have to put it in parentheses. So now when we do the math, 4 times 15 is 60 equals, here to do this, we have to distribute because we cannot add 4 and X, but we can multiply 5 times 4, and we can multiply 5 times X. So 5 times 4 plus 5 times X. So 60 equals 20 plus 5X. And we subtract 20 from both sides. These will cancel. 40 equals 5X. Divide both sides by 5 to isolate the variable. And X is 8. The alternative method for doing the same problem, everything would be the same except for at the point that I am looking to plug in, I'll assign this entire length a new variable, and let's call that y. So now, the small side would again be 4 over the base, which is again going to be 5. But this time, instead of EF, I'm going to call that Y. So instead of EF, we're going to call this Y over DF, which is still 15.